So today I'm talking about some fireworks. So my name is John Gray. I'm going to do a fiery analysis of the chemistry involved in fireworks and exploding. So fireworks have been a huge part of our society for almost over 1,000 years. So we're going to go over some stuff. So first we're going to talk about the components of a firework, the thruster, and the aerial shell, which is the most important part, which are the colors and the explosions form. This is the part that everyone wants to talk about. So inside a firework, there's a lot of stuff going on. We got a fuse, a motor, a head, and obviously the stick so you can hold it. Or if it's a mortar, then you have a mortar too. But basically when you light the fuse, it's going to light the lifting charge, which propels the actual firework and the aerial shell up very high because of the expanded gases. The amount of heat and kinetic energy released from this reaction is quite high. And once it's high enough, this timed fuse will finally ignite the gunpowder inside the aerial shell, which release these beautiful salts, which create beautiful patterns and colors. So yeah, a lot of this is held together with the polymer dextrin, which is quite common in the hydrolysis of, it's a product of the hydrolysis of starch, I believe. It's kind of like a glue. They kind of use it like a glue in this situation. So for the thruster, we have the combustion of black powder. It is essentially the fuel for flight in this situation. And one of the byproducts is a lot of heat, which is quite important, especially later on. It is granuled. It is not a powder. It is granuled, which is like a small marble kind of thing. And it creates a huge force to lift this firework quite a high away from you to be sure you're safe. And this is kind of a exaggeration of what it looks like. This is a rocket launch, but it's essentially, get the idea down. It propels this thing quite high. The aerial shell itself is where all the magic happens. This is where the black powder inside here is combusted, and the heat here is very, very important for what I'm going to talk about, which is the salts. The salts, they generate different colors, but why is it that strontium will generate a red color, but copper and barium generate blue and green? Like, what is it about these compounds that generate different colors? And the color of the flame is directly related to the size of the salt. So directly related to the amount of protons and neutrons and the size of the molecule. And this is a copper oxide burning. So you can see it has that nice blue and a bit of green as well. It's probably just the environment affecting it. So when you heat a compound, or when you're forming or destroying bonds, the electrons are moving around. So when this electron returns from the excited state to the its ground state, it's going to release energy. And the amount of energy it releases is relative to the size of the electron and its affinity. I mean the molecule and its affinity, electron affinity. So for strontium, it has a lower electron affinity than sodium or aluminum or anything above here. Strontium is pretty low. And because of that, it generates a lot lower amount of energy, which creates a bigger wavelength in nanometers. And for visible light for us, that's going to create a nice red glow. Whereas if we go to copper, on the affinity, it's much, much higher. It's going to generate a lot more energy, much shorter wavelength, so you're around 475 nanometers. Gives you a nice blue glow. But let's see a huge firework explosion, shall we? Count the seconds the fireworks in the air for. So as you've seen there, the firework is actually in the air. The lifting charge has it in the air for about 16 to 18 seconds, which is quite long. So you see these fireworks are extremely volatile and they can be extremely dangerous if you don't time that timing fuse correctly. It's vital that you have that fuse going for as long as you need it to get that firework as far away from you as possible. And you can see even just right after it explodes, those shards are coming down. They're coming down around to the ground and illuminating this area quite a lot. So yeah, that's a firework overview of how they work. why they work and different colors involved. Thank you for watching, and I'll catch you all later. There goes that.